Last lesson we learned how to name multivalent compounds, in other words, things that have more than one charge, and that would be our metals that we're talking about that have more than one charge. So now, instead of using the stock system, which is what we learned yesterday, we're going to use the old system. And you've heard some of these words before. It'll sound familiar to you. The difference being, with stock nomenclature, again, that's what we used yesterday, we used Roman numerals to distinguish among the ions. So whatever your metals were, you had to say what that charge was, what that oxidation number was, with a Roman numeral. So now what we're going to do is we're going to use an older system, but instead of using Roman numerals, it will have endings of us or ic. And the way we make that distinction is that the us ending is going to be the ion that has the lower charge, and the ic ending is going to be the ion that has the higher charge or higher oxidation number. So according to our old system, let's look at this example here. If we have Cu2O, then this would mean, according to our stock system, what we learned yesterday, is that that's going to be a copper oxide. You would say, well, this is a -2, and that means this has to be a +2. So you have two of them, so each one has to be a +1. So that's going to be a copper 1 oxide. Well, now what we're doing is we're taking that a little bit further, and we're saying copper 1, and again, you're just going to have to memorize these charges, and you'll see that list here in just a second. But that copper 1 is going to be the lower oxidation number. So since it's the lower oxidation number, you use the us ending. Here we have a -2 for our oxygen, meaning our copper has to be a +2, and there's only one of them, so that one copper is copper 2 oxide. That's your stock system. Now for our old system, copper 2 is the higher charge, so that means it's going to have the ic ending. It becomes cupric oxide. So here's that list of the valences, the charges or oxidation numbers of the different elements. You do have to memorize these. A lot of this is going to make sense. It's going to help you understand why some of these elements have the symbols that they do. And the other recommendation I have for you is you've been recently given another periodic table, so why not just go ahead and put those on your periodic table and write down the charges. I'm not going to do it on here, but for example, this would be a +2 and a +3 would be your two possible charges or oxidation numbers that you have for chromium. So if you write those down, it might help you. You might see a few patterns that will be helpful in memorizing this. Okay, so now it's time for our examples. First one, what we're going to do, let's see, it says to go ahead and name each of these using the stock system and the older system. So I'm going to do the stock system first, and then we'll come back and do the older system. So I'm going to do the stock system really quickly on most of these. I'm just going to say this is copper 1 chloride. HgI2, and I'm going to do this a little differently. I think I'm just going to go down and do all the stock system first. HgI2, mercury, this is when you should just be a little bit suspicious. Remember that mercury is one of those odd guys that you can have. If it's mercury 1, it's a little bit different. So just be wary. We know that iodine has a -1 charge, so therefore we have a total of -2, meaning we have to have a total of +2. And in this case, that's all it's going to be is just, there's one of them, so it's just mercury 2. Nothing weird about that one. And that's iodide. Okay, next we have gold, and bromide is -1, so that must mean our gold is gold 1. We have an iron nitrate. Nitrate's -1, so our iron must be a +2. Here we have a tin sulfate. And in this case, our sulfate is -2, so our tin must be a +2. Here we have a tin chloride. Chloride's -1, so that must mean our tin is a +4. Then we have iron phosphate. We know phosphate is -3, so our iron must be a +3. Then we have a mercury. Again, we're thinking about this. Could be weird, so beware. And then we have an oxide. I know oxide is -2. And I've only got one of them, so that gives me a total of -2. So therefore, I have to have a total of +2 for my mercury. But we've got two of them, so each one of those has to be a +1. This is that weird little situation where mercury is a diatomic elemental ion that we talked about yesterday. And in this case, we didn't have to really do anything too strict. Well, I'm not even going to go on about that. We just went through and we calculated it, so we see that's mercury 1 oxide. Okay, next one we have cobalt. And that's going to be a phosphate. So write that down. So phosphate's -3, cobalt will have to be a +3. And then finally we have lead. And it's going to be a sulfide. I know sulfide is -2, but we've got two of them. That gives us a total of -4. So that means we must have a total of +4. So our lead is going to be a lead 4 sulfide. Okay, so that was really just review for us, but you really have to think about it in those terms. You should be thinking about the charge of your metal ion, which is what we just did. So now what we want to do is look at the new stuff, and you've got your chart in front of you. You're just going to go through and name using the older system, remembering that your us ending is used for the lower oxidation number, and the ic is used for the higher. Maybe I'll even write that. Us is lower, ic is higher. So ultimately, you're going to need to be able to do this without looking at your chart. Copper can be a +1 or a +2, so here it's a +1, so that's going to mean, sorry, I can't write here. That's going to mean it is cuprous chloride. Mercury can be a +1 or a +2, so this is going to be a mercuric oxide. No, sorry. Iodide. Gold 1 can be a +1 or a +3, so that's going to be, I'm never very good at pronouncing this, but I think it's auric is the best way to pronounce that. No, RS, because we're looking at the lower. So RS, and it's going to be bromide. Then we have iron. Iron can be a +2 or a +3, so this is the lower one, +2. So that is going to be ferrous, and it's nitrate. Tin can be a +2 or a +4, so that is going to be stannous. And we're looking at sulfate. And then we have tin 4 is just going to be stannic. That's your higher charge. And this is chloride. Iron 3, that's higher than the iron 2, so that one is going to be ferric. And phosphate. Mercury 1, so that's going to be your lower charge, which means it's going to be mercurous, and that's going to be oxide. Cobalt 3, cobalt can be a +2 or a +3, so 3 is the higher, so cobaltic, sounds like an ocean, cobaltic phosphate. And finally, lead can be a +2 or a +4, so the lead 4 is going to be plumbic. And that's sulfide. So again, might be helpful in understanding why lead has the symbol Pb, so this might kind of help reinforce understanding your symbols. Okay, we're going to work in the opposite direction, and then we'll be done. In this case, we want to write the formulas. So in all of these instances, we're told the old system. So we have to think about the us means it's the lower charge. So if I see cuprous, I just need to remember that that's copper, and copper can be a +1 or a +2. This is going to be a +1 because it's the lower charge. So +1 for my copper, hydroxide's -1, so we're done. Mercurous, I need to remember that there can be a +1 or a +2. This is +1. That's the one that's a little weird, so we have to think about that. Mercury 1, the way you would write that is Hg2 with a +2 charge. So notice how I changed that. Hg2 with a +2 charge because it's a diatomic elemental ion. And then nitrate is NO3 and it has a -1 charge. So now in order to make this electrically neutral, I need to have 2 nitrates. And then we get into ferric sulfate. Ferric is going to be the higher charge. I know it can be +2 or +3, so it's going to be iron with a +3. Sulfate is SO4 with a -2, so that means we're going to have Fe2 SO4 3. Auric sulfide, that tells me it's going to be the +3 charge, which is the higher one. So gold is Au, that's why that's the symbol. And then sulfide is S with a -2. So in this case, we're going to have Au2S3. And then we have plumbous nitrate. So that's going to be Pb, and it's plumbous, so that's going to be my +2 charge. Nitrite, I think I might have missaid that. Nitrite is NO2 with a -1 charge. So in order to make this electrically neutral, I need to have 2 of them. And then the last 5 that we've got. Stannous fluoride, there's 10, and it's going to be the lower charge, which can be +2 or +4, so this is +2. Fluoride, -1, so SnF2. Ferrous, there's our iron, which is going to be our lower charge, +2. Sulfate, SO4, which is -2, so we're done. It's electrically neutral. Stannic, Sn, it's the ick, which means +4. Chromate is going to be CrO4, and it has a -2 charge. So in this case, if you're just trying to crisscross, you might get yourself into trouble. So make sure you think about making it electrically neutral. I need to have 2 of my chromates in order to make this electrically neutral. So that's what we would do there. Okay, cupric, that's copper. It is going to be the +2, the higher. And phosphate is PO4, -3. So it's going to be Cu3, PO4, 2. And our last one, nicolic, Ni, it's going to be the higher charge, so that's going to be a +3. Carbonate is CO3, which is -2. So Ni2, CO3, 3. And we are done.